morning of January 17, 1966, a B-52 aircraft carrying nuclear weapons collided with a tanker aircraft during routine refueling operations. The collision broke loose 4 nuclear weapons. The high explosive in 2 of the weapons detonated upon ground impact, scattering plutonium over a wide agricultural area. The accident occurred in the vicinity of Palomares on the southeast coast of Spain. Although the detonation of the high explosive caused no loss of human life, the cost of cleanup operations has run well over $50 million, and monitoring of the area's populace, soil, and farm products continues to this day. This accident, and the possibility of others, increased the emphasis at the Los Alamos Scientific Laboratory to develop an insensitive high explosive to enhance nuclear weapons safety. This Los Alamos developed insensitive high explosive, PBX-9502, consists of 95% triamino trinitrobenzene and 5% Kel F800, a plastic binder. PBX-9502 is formed into the desired shape by molding and machining in the same manner as PBX-9404, the explosive commonly used in nuclear weapons. In a series of tests conducted by the Los Alamos Scientific Laboratory and Sandia Laboratories, Albuquerque, these 2 high explosives were subjected to intense thermal and high-impact environments. In the first test, samples of insensitive high explosive and PBX-9404 were each confined in heavy steel pressure vessels. Each assembly was wrapped with electrical heat tape, surrounded by insulation, and heated at a rate of 122 degrees Fahrenheit per hour. At 570 degrees, thermal decomposition of the insensitive high explosive caused a pressure buildup that broke the container lid, but detonation did not occur. In the experiments with the PBX-9404, detonation occurred at 290 degrees, entirely destroying the pressure vessel and its container. Large-scale model impact tests using identical quantities of high explosive were performed on a pull-down facility. The target consisted of layers of steel and reinforced concrete. In this first test, a model laydown bomb containing insensitive high explosive strikes the target at 850 feet per second. The insensitive high explosive does not detonate. Here, a model containing PBX-9404 strikes the target at 440 feet per second. The high explosive detonates. These tests were followed by impact tests of bomb mock-ups on a sled track. Test conditions for the test units were identical. The target for these tests consisted of reinforced concrete backed up by sand and a steel containment box. Here we see a test unit containing insensitive high explosive accelerate to 500 feet per second and strike the target without detonation. In this test, a unit containing PBX-9404 is also accelerated to 500 feet per second. It strikes the target and detonates. In a split-screen close-up of these tests, the insensitive high explosive unit is on the left half of your screen, and the PBX-9404 unit is on the right. The PBX-9404 explosion is very similar to that which contaminated almost 400 acres of land in the Palomares incident. Had insensitive high explosive been available at the time, contamination would have been a small fraction of what it actually was. Since the insensitive high explosive would not have detonated, the cleanup problems would have been much less complex. In fact, the fragments of the weapons would have been recoverable at the impact site, as these fragments were recovered after a severe impact test of the insensitive high explosive PBX-9502. How do we detonate insensitive high explosive? In this test, we intentionally detonate an insensitive high explosive system. The detonation was initiated by the 1E34 detonator. This detonator was developed by Los Alamos especially for insensitive high explosive, and tests have shown that the new detonator system is safe, reliable, and effective. Recent versions of the B-61 bomb incorporate both the insensitive high explosive and the 1E34 detonator. The use of insensitive high explosive has significantly increased high explosive safety in the manufacture and transport of nuclear weapons, as well as in all related military operations. Insensitive high explosive has also provided an important additional safety factor in such eventualities as accidental airdrops, plane crashes, and fires. The development and evaluation of the insensitive high explosive PBX-9502 is part of the continuing joint effort by Sandia Laboratories and the Los Alamos Scientific Laboratory to provide enhanced high explosive safety for nuclear weapons.